Right. This is continuation of yesterday. Today is the 12th, 29. So this is just from yesterday, continued from yesterday. Words are hard. So our example 5 is this. All right, let's get this done. What do we do first? What do you mean by that? Okay.
You have to get the one by itself.
Yeah, and y is already conveniently by itself. Sometimes it will be, sometimes it won't be, but your objective is to pick one of the equations and get y by itself so that we have something to substitute in. So y is equal to this. Therefore, this, represented by the red box, will go right there. So the top equation now says x squared minus blank squared equals 3. Remember where y used to be, there's no longer a y. There is, however, his other name, x plus 3. And we remember yesterday, we spent 5 or so minutes practicing this math problem in the yellow bubble right here. The yellow bubble is, remember, not x squared plus 9. We talked about that. So what is going to be the square multiply double for that yellow bubble?
6x.
So we have x squared plus 6x, you say, plus 9. Perfect. So remember, the x squared and the 9 come from a very obvious place, namely x being squared and 3 being squared. The 6x comes from multiplying the two things in the parentheses, the x and the 3 to get 3x, and then doubling that to get 6x. Okay. And I left the parentheses on this time because there's a minus that needs to be given full respect. So that minus, I need to let myself see that it's a minus distribution. So I'm going to rewrite the problem now as x squared, and then I'm going to distribute the negative as minus x squared minus 6x minus 9. Yeah. And that's not a negative 3, so that's just a 3. Okay. And then this is one of our favorites. We come to appreciate these hyperbola ones because we recognize that the x squareds are, generally the way I'm writing these, it's not a guarantee, but the way I'm writing these for you, predictably, the x squareds are going to cancel out, which is great news because that means it's no longer a quadratic equation. So if x squared minus x squared goes away, we're just left with a nice little simple 8th grade-y kind of problem here. So we have negative 6x equals, add the 9, you get 12. What's x? Right. So that means that the line and the hyperbola will only cross in one point, and we can find that point with knowing that his x we already found, and the y we just have to go on a very simple hunt. And how do we find the y? Put it back in that nice box that, of course, we all drew. And if you put it right into that box, negative 2 plus 3 is 1. So we could rest assured if we graphed it, that the hyperbola and the line would intersect at the point negative 2, 1. Any questions about that? All right, let's do example 6. Nothing to it, right? Example 6 is a line and a circle. So we have x minus y equals 3. And we have x squared plus, as soon as we get that plus in between the squared, then that's when we know it goes to an ellipse. Specifically, in this case, the type of ellipse is called a circle. It's a non-stretched circle. So in the next class, if you go on to take the harder class, we'll talk about these and what starts happening if you mess with the x and the y. is you start to pull the circle and it becomes what we call an ellipse. It's like an oval, essentially, and it can stretch vertically or horizontally. But all of ours are just going to be nice, simple, symmetric circles. So that's that. So again, step one, what is it? Get y by itself. And that means that we should take this top equation and I'll be real careful. I would take the negative y and I would move it to the other side. And then I would leave the x where it's at. And then I would subtract the 3 across. I I do stuff like this, and I know that it might drive some people crazy, but in reality, what the equation would have looked like if I had really respected the whole left and right nonsense is the y would have come to this side, the x would have stayed on this side, and the 3 would have gone to this side. So if you get uptight about stuff like that, then that's for you. So that's all I did. I just in my mind just reflected it because I'm a y on the left kind of guy, but no one actually cares. Like it doesn't matter. All right, so y equals or something equals y. Doesn't matter. Mission accomplished. Y is by itself. We're going to box this sucker up and we're going to put it right there. All right, starts to feel kind of like the same process. These circle and hyperbola ones, they start very identically. They just don't end. Like this one's going to still be a quadratic when we're done because there's not going to be a minus x squared to cancel the other x squared. So anyways, this equation, if we rewrite it patiently, bless you, I'm not going to skip any steps, is going to be x squared plus blank squared equals 13. And into that blank is going to go the contents of the red box. And then again, we're gonna never miss a square square multiply double ever. That's just becomes one of those little tiny skills that we don't want to keep slowing ourselves down with nonsense like this. So what is the answer to that squared problem? It's x squared minus 6x plus 9. And the process, again, I know some people don't know, but they don't like to ask, is this. I take this x and I square it, and that's where x squared comes from. I take this negative 3 and I square it, and that's where this plus 9 comes from. Will the first term always be positive and the last term always be positive? Yes, because we're squaring things to get them. So that's not up for debate. Like the red check mark one and the green check mark one have to be positives. And then the one in the middle will just be determined by whatever it is. Like if I multiply red and green, those Christmas ones, put these two things together and you get minus 3 or negative 3x, right? And then you double that, and that's what you put here. It's just rinse and repeat. Like there's nothing deep about it. But like I said, with these circle ones, we don't get the lucky cancel. So we do have to deal with a quadratic. So what happens is these two terms are like terms. They don't go away. So instead of no x squareds, we have 2 x squareds. And what's our thought process? What's our like MO when we have this? Not yet. Subtract the 13 first. We have to go back to the old basics and say, get all yo stuff on one side. When solving a linear equation, you want to separate and divide. You know, like 8th grade problems, we separate and divide. These types of problems, quadratics, we want to push everything and set it equal to 0. So if we take the 13 and move it, we're left with 2x squared minus 6x, and 9 minus 13 is minus 4. And now we have a quadratic equation that we can attack. And now we're ready to take a GCF, right? Because we want to factor this, but factoring is a lot easier if I can get any GCFs out of the way. You learned that back in September in this class, that GCFs just gum up the works, and this term and this term and this term can all be divided by 2. And so we're left with x squared minus 3x, and I wrote another bad problem. Good for me. Good. So listen, I vetted the demon out of your assignment today, but obviously I need to get good noob when it comes to writing notes. This one, can you see why this isn't going to end well for us? Well, I mean, if you don't know the answer to that question, it's because this is not factorable, correct? So this is the second time it's happened to us. And I didn't mean for this to happen. Could we finish this problem? Absolutely. Do you want to do the quadratic formula with me? We can, if you don't want to. Do you want to sing it with me? Kane, you want to sing with me? The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. That was really good. Thanks, Kane. I think I'll give you some candy. I appreciate having a singing partner. Yeah, let's just do this. You know what? Why? I'm just not I was gonna take the lazy route and just fudge it, and let's just do this. Let's just man up and do it. Hugo, you down?
I would be, but I don't have any more space.
Turn the page, homie. Yeah. That's the last page in your notebook?
No, but I got everything on one.
Oh, sorry, buddy. A is 1. What's B?
Negative.
And what is C? Nice. So this isn't going to be a perfect thing, because it's going to be a little ugly, but whatever. This is good practice for us anyways. And like I said, I didn't feel like just fudging it. So let's just do what we came to do. Let's solve it as is. And I'll do the same thing with 8th hour. I'll put them through this too. So to do the quadratic formula. And that's the nice thing about the quadratic formula. I guess the lesson to be learned here is that it just always works. It literally always works. So we're going to say that x equals what? 3.
Square root of 9 minus 4.
Sorry, did you just say the square root? Sorry, minus 4 blank blank all over what? 2. And in the blanks go what? Perfect. Right. We've been down this road before. And so we're going to solve. We're going to simplify first. You have to, does anyone by chance, 2 pieces of candy on the line, if you can tell me what that yellow thing is called? Starts with a D.
Difference.
Nope, it's called the discriminant. So no, you didn't. So we have x equals 3 plus or minus the square root. And if the discriminant comes out negative, then there is no real place of crossing. But this one will come out positive because the minus is going to change into a plus. So it's going to be the square root of 17 all over 2. So we do wind up with 2 crossing points in this case. And I think to keep us all sane, what we're going to do is let's break them out first of all. So let's consider one of them to be, it's really important that you take away from algebra 1 and algebra 2 that this is not an answer. It is 2 answers, right? And so one of them has a plus. So if we consider the one with the plus, his name is 3 plus the square root of 17 over 2. And the other one is 3 minus the square root of 17 all over 2. Now, in order to get this lesson going, what we're going to do, just to save our sanity, is first we're all going to grab our calculators and we're going to come up with pretty good approximations for what these are, rather than keep them in their perfect form, because that would be a little bit nightmarish on the calculations. We could do it, just kind of suck. Let's figure out what these are as decimal approximations. So I'll type it in and you type it in, and let's just make sure we're on the same page. Don't forget that you have to hit the equals or enter sign after you do the top. Otherwise, the calculator will do this division problem first. So like if you just type in 3 plus root 17 divide by 2, it's going to divide first. You don't want that. So force it not to by either using parentheses or hitting enter. So I'm going to do 3 plus the square root of 17, and I'm going to hit enter. Don't really care what that equals. And then while it's on my screen, I'm going to hit divided by 2. And let's call this about 3.56. Okay. But none of them on your homework are going to do this. I photomathed them all this morning just to make sure, because I didn't, I don't trust myself. I guess I'm a little on the, what's that? I guess a little gun shy. And then we have to do the other one, which is the same math, only with a minus. So we're going to do 3 minus the square root of 17, and we're going to get negative something we don't care about. We're going to hit divided by 2, and we're going to get negative 0.56. And now that we have a more tangible sort of sensible number, and you could do that to any degree of accuracy. You know, if you had a teacher that said, I need 5 places, then you would just round it to 5 places. Like, it doesn't matter. This will be okay. This will do. And so how do we find the y's to go with those guys? And plug them in. And hopefully we have a box laying around someplace, and we do. It's way back up there. So our answers, remember, so we had y equals x minus 3. I'm going to pull that back down here. So earlier on in the problem, we figured out that y is equal to x minus 3. That was like 5 minutes ago. So we're going to take those two numbers and we're going to plug them in. So if I took 3.56, I don't need a calculator for this part. If I put 3.56 minus 3, what do I get? I just get 0.56. Good. And then if I put in negative 0.56 and I take away 3 more, what do I get? It's negative 0.56. It's not 0.56. It's negative already minus 3 more. What do we get? Negative 3.56. If you already owe someone 56 cents and you borrow 3 more dollars, you owe them $3.56, right? So just to finish this off and make it feel pretty sweet, let's Desmos this bad boy real quick, just because why not, right? Because that'll be fun. Desmos is the best. So for my first one, I'm going to type in x minus y equals 3. You can type in your equations in any format. Desmos will take it any way you've got it. So, and then the other one was x squared plus y squared equals 13. And then I'm going to zoom out. And there's our 2 crossing points. And if I zoom in on them, like if I click right on that, you can see we did a pretty good job. So there's our 3.56 and our 0.56. And then this one over here is our, I got to make a point up here, negative 0.56 and negative 3.56. Pretty rad, huh? So didn't mean for that to happen, but I guess it was a nice little journey to get to take. So if it ever happens to you, now you know, you don't go, oh, what do I do? You just use the quadratic formula, your bestest math buddy, and it works, doesn't matter. We just like the nice ones, but we can handle the bad ones. I'll pause the recording, hand out your assignment. If you have any questions, then of course the recording will be ready to roll. If this is the end of the recording, then that means no one had any questions. Resume recording. All right, question 1. So we have x plus y equals 1 and x squared plus y squared equals 13. So we're obviously going to take that top equation and say that y equals negative x plus 1. And then we're going to take this and we're going to put it in here. And we're going to have x squared plus blank squared equals 13. And then we're going to put our boxed contents in there. And then we're going to perfectly execute the square multiply double in the yellow box. We're going to have x squared plus, and I don't need any more parentheses because it's a plus sign. And plus won't need distributed, so I can just do the yellow box, which is square multiply double. Good to hear? Okay, so now when we put these two like terms together, we get 2x squared. We leave the minus 2x, and then we subtract 13 across, giving us minus 12. Did you put something silly like 14 or something like that? So you ready to move on? So now we're going to look at all 3 of these terms and identify that we can pull a 2 out of them. And we're going to be left with x squared minus 1x minus 6. You should always pull a GCF out of a quadratic equation 100.0% of the time. If you look at an equation that has x squared, it's called a quadratic. And we're going to go and try to factor it. And factoring is super mega million times easier if we don't have a GCF making the numbers bigger than they need to be. So that's why we always pull it out. And that 2 no longer has any relevance in the problem because it doesn't have any X with it. Then we can just chuck it, throw it in the trash, throw it in the trash can. Now our job is to recognize that we have to factor down this. Get to work back there, would you? Quit that. And what are our signs going to be? Yeah, I mean, you said that as if you were guessing, but I mean, the fact of the matter is the number in the back has a minus, and that just makes it literally not up for debate. The only way to multiply 2 numbers in these 2 yellow blanks and get a -6 is to have one of them be positive and one of them be negative. Like that's not a question. That is not even debatable. And now we just look for numbers that simply multiply to make 6. And we're limited on our options. We have 1 and 6, or we have 6 and 1, or we have 2 and 3, or we have 3 and 2. And because we're trying in the center to get the end game to be -1x, clearly we want some combination of 2 and 3. Because either 2 minus 3 is -1 or 3 minus 2 is +1. And we're looking for a 1 in the middle. So we want it to be +2 and -3, because we know they'll multiply to make -6. Like that's easy. But what we had to make happen is make sure that this 2x minus this 3x equals -1x like we wanted. Right? Just a factoring 101 there. And then we can now say that the answers, this does not produce an answer because it doesn't have an X, but this produces an answer. What makes the first parentheses equal 0? These parentheses, the first ones. What could you put in place of X to make that cancel out? -2. And what makes the second set of parentheses equal 0? Good. So what we know right now is that our answers look like this: -2, comma, blank, and 3, comma, blank. Those are our X's. Therefore, we need to find their corresponding Y's. And where do we go to find the corresponding Y's? Into the box. And just about every problem is going to have a box. I mean, if we don't have one, then we'll just plug it in place of X in some random place and solve for Y. Like, I mean, that's just what we do. But the box is the easiest thing in the world. So we'll start with -2. So if I put -2 right there, I just have to do some little kitty math. -2 plus 1 is -1. So then I can know now that the answer to this one is -2, -1. And then I just do it again, except this time I replace it with a 3. And I say, okay, what's -3 minus 1? -3 plus 1, just doing the red box, is -2. So then I just put that in here, and I am done. Okay. You'll have to factor on 4 out of the 6 problems. 2 of them, the X squareds, will cancel because if this sign, I'm going to circle this in the most obnoxious way I can think of. If this sign is a minus, then you see that the X squared minus X squared has a chance to cancel. And when the X squareds go away, then we don't have to factor. We're just going to solve some little rinky dink. Like, you might wind up with, like, I don't know, something hard like -4x plus 6 equals like -10. And then you just, I just solve it like a kid would, right? Subtract and divide. So if the X squareds go away, all right. If they don't, then you better know how to factor. Better?
Thank you.
You sure?
Oh,